In this video, we're going to take a look at how we can use Excel to answer some of the problems related to correlation that we've been looking at. If you already watched the video on using the TI-84 calculator, you'll notice that this is the exact same problem. So I'm just going through that exact same problem. The problem states that the following table shows the percentage of third grade students proficient in both reading and math in 10 states. And it has the list of each state here. Again, they appear to be basically just the most populous states. It has the percentage of students proficient in reading in this column and the percentage of students proficient in math. So for example, for California, 60% of their students are proficient in reading, 59% in math. And so that gives you the ordered pair for each state, our ordered pair x, y values that we're going to be using. We're asked to compute the correlation coefficient, to compute the least squares regression line, and then to basically use the least squares regression line to predict math proficiency in New Mexico if reading proficiency here is 65%. And so I've got the data typed into Excel over here. These numbers should match these, so these numbers over here should match these numbers exactly. And I just want to show you how we can compute these various things. So for part A, I'll come down here, and we're going to start off with an equal sign, because the function that we're going to use when it comes to finding the correlation coefficient is a function that we just start typing, and sure enough, after we've got C-O-R-R-E-L is the correlation function. So I'll double click that, and it'll ask for two arrays. Basically, the arrays that it's interested in are our x values and our y values, and I've got them over here. So the first array I'm going to do in this case, and it doesn't matter the order in this case, we can pick either, but I'll do these, which are x values first, and then do comma, and drag to select the y values in this case, and close our parentheses, and hit enter, and sure enough, we get the exact same correlation coefficient that we got when we did it using the graphing calculator. So in this case, it's a pretty strong correlation of about 0.809 if we were to round to 3 decimal places. So this is the value of R. Normally we would write that as our value R. If we're interested in the least squares regression line, so our least squares regression line, it's going to require two distinct values. So based on this, I'm going to come over here and I'm going to write the value that we just found for our R. R was equal to 0.809-ish. And in a second, we'll do the least squares regression line. So let me get this back on the screen so we can see it. For the least squares regression line, in Excel, the function that does this is something that gives us a linear estimate. And so if I start typing lin est, oops, I forgot my equal sign. So if I do equals L-I-N, you'll see that lin est is one of the first options. And so that is going to be the command that will do this. And it will tell you specifically what we're looking for. It's going to ask for the known y values before we plug in the known x values. So just to reference our table here, the y values were the math values. So I need to put in this column corresponding to the math scores because that's my y values. That has to come first. So in this case, I need to make sure I'm doing the y values first. So here are my known y values, then do a comma, and here are my known x values. You can see that's highlighted here as we do those. And if I close my parentheses, so you see that there's some other options after that. These options are not required. I'm just going to close my parentheses and hit enter. And notice it gives us two different values. One of them is the slope of our line, and the other one is the y-intercept of our line. So essentially, if I come back over here and were to try to translate this into the equation for the line, let me zoom in so we can see a little better. You'll remember the equation for the line is y hat is equal to something times x plus something else. So something x plus something else. And depending on if you're looking in the calculator, these are maybe it's ax plus b, or it could be a plus bx, so this could be the b and this could be the a. Or in the book, they use b0 and b1. But for us, what's important is over here, it's always going to give us the slope first, so the one that should be multiplying the x value first. So in this case, it's about 0.823. So 0.823, if I were to round that to 3 decimals, plus the second number, 11.036, if we also rounded to 3 decimals, 11.036. And so these two numbers here came from these two numbers here. And that gives us, let me get this all back on the screen at once, that gives us the equation of our least squares regression line. So this is the line that would best fit the scatter plot for this data if we were to have a scatter plot of this data. The last thing we want to do is use the least squares regression line that we just came up with to predict math proficiency in New Mexico if the reading proficiency is 65%. So what it's saying is it's giving us a known value of the reading proficiency. And if I come back up to our table, reading proficiency is our x value. So basically, we have a known value of x, and we want an unknown value of y, right? What we want is the math proficiency, so a y value. If we look at our equation, it's set up so that we can plug in a value of x, and the whole thing will spit out a value of y. And so that's all we have to do. This is the equation I'm going to use. I'm going to plug in 65%, and when I plug it in, I need to plug it in the same format that these numbers over here are, right? We've already said that it shows the percentage, so I don't need to convert this to a decimal and have it be 0.65, because none of these numbers are written as decimals. They are written as like the whole number percentage. So because these are written as whole numbers, I'm going to just plug in the number 65. So what we would do to find the y hat value of our choosing is plug in, sorry, let me get this all on the screen again. Well, I'm just making it worse. Okay, good enough. 0.832 times the value of x, which we just said is going to be 65, plus 11.036. So I just need to plug that in. And we can do this over here if we want. So if we want the New Mexico math score, I can do that here with an equal sign. We can type in a formula. It doesn't have to be these fancy pre-made formulas. We could type in the type of stuff that we're doing here. So I could do, in fact, if we want to keep all the decimals, I could even just click on this entry here and it will put all the decimals, or we could just type in the one that we rounded here. So I'm just going to do the one that we typed in. So let me delete that and just write 0.832. Here's the time symbol, just the basically asterisk symbol is multiplication, times 65 plus 11.036. And now if I hit enter, there it spits out the predicted math score, which in this case is also going to be about 65%, just a hair over 65, so 65.1. And that would be the percentage of students in New Mexico predicted to be proficient in math based on the 65% that were proficient in reading. There's one other thing I want to point out, and that is on the exam, if you're doing this, the spreadsheet on the exam doesn't quite work the same way as this one does. So if you're trying to compute the correlation coefficient, let me come back to this, it is absolutely the same command. It works exactly as expected. But this linest command down here doesn't quite work the same in the lockdown browser. So what you would have to do in the lockdown browser, and let me just, I can do it here, so let me just type this in. In the lockdown, if I can type, browser. For the least squares regression line. Okay, what would we have to do in that case? Well, it's the same command, but to do it, you can't just click into one box and do both. you have to actually drag and pre-select two boxes. The reason for this is because it spits out two numbers. In Excel, it's smart enough to, even though you only clicked on one box to enter the command, it's smart enough to know that it's going to spit out two values and it knows where to put them. But in the one in the lockdown browser, it doesn't know to do that. So you have to start by highlighting two squares, then start typing equals linest. Do the same thing as before. So do your known your known y values first, comma, your known x values. Close your parentheses, and here's the other thing that changes. Instead of just being able to hit enter, you have to hit Control Shift and enter, at least on a Windows keyboard. On a Mac, I think it's instead of Control Shift enter, it's I'll have to look that one up. So if you're using a Mac and you're planning on doing this, let me know and I will look this up because I don't have a Mac. But Control Shift enter, and it will spit out the two numbers for you in the same way that doing it this other way did. So I'll write down these extra commands here. So again, just as a side note, note in the lockdown browser, and again, we're talking just for the least squares regression line, what you have to do is step 1, highlight two squares, or two boxes, I should say. So two side by side. Step 2, type in equals the linest parentheses, whatever your y values are, comma, whatever your x values are. So again, these are just placeholders for where you put the entries, and close your parentheses. So this is just a placeholder for the list of column entries where the x and y values are. And then for step 3, you don't just hit enter. You've got to hit Control and Shift and enter all at the same time, and it should spit out the correct value for you. So again, this is if you're using this in the lockdown browser. So it's just one extra little wrinkle to remember, worth putting on your note card if you don't think it's something you will remember if you're using Excel. So just keep that in mind. And again, on Mac, they have those other buttons. I think it's like, I want to say it's like Apple button, Shift and enter at the same time, but I'm not 100% sure on that. So don't quote me on that. If you're using a Mac, I'll try to look it up and see if I can figure out what the set of buttons is that you need to hit on a Mac if you're doing this. Okie doke. Otherwise, good luck on this homework. I'd encourage you, please utilize either Excel or the calculator. Do not do these problems by hand. Get them done this way.